Okay, so good morning again, everyone. Thank you for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course, which will be posted on 3C Ren's on-demand page. We have Steve Mann from the Passive House Network and Home Energy Services with us today to talk about the Passive House Standard. But before we get going, I just have a few slides to run through. We ask that everyone make sure that they're on mute throughout the duration of the course. If you'd like to verbally participate, please raise your hand and we'll call on you to unmute yourself. We encourage you to participate and ask questions throughout the chat as well. We'll be monitoring the chat box. So a few words about who we are. We are the Tri-County Regional Energy Network, also known as 3C Ren. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren currently offers 3 programs. Next slide.
Sorry.
No, it's okay. Thank you.
Okay.
Energy Code Connect program serves building professionals by offering trainings and support to make the Energy Code easier to follow. Within the Energy Code Connect program, we have our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24, Part 6, and Part 11 related questions for both residential and non-residential projects. And then our next program is our Building Performance Training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles and high performance buildings. Today's class is brought to you from the Building Performance Training program. And then our third program is our Home Energy Savings Program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Steve.
Thanks very much, Sarah. Glad you could all join us this morning. I've been looking at the chat a little bit. We have a nice, interesting mix of folks, architects, designers, certified energy analysts, general contractors. So a little bit of everybody that we want to tell about the Passive House Standard. Excuse me. So I'm going to go ahead and just do an introduction. This is a fairly short webinar. The Passive House Standard is a deep topic. The formal training to get certified as a passive house designer or consultant is basically a 5-day training course, followed by a fairly rigorous 3-hour exam. So with that in mind, I'm just going to be skimming the surface, just to give you a flavor for what it's all about, and hopefully get you interested into continuing to dive into this topic. I've been doing passive house things for 12, 13, 14 years, something on that order, and I'm still learning new things. It's a deep topic. For those of you that have a short attention span or you get bored easily, this is the kind of thing that could keep you interested for, at least a good 10, 15, 20 years, I think. So with that, the Passive House Network, who is sponsoring this presentation, is a North American organization. It's a nonprofit based out of New York. And their primary mission is education, training, and sort of spreading the Passive House word. There are Passive House organizations all over the globe, and there are Passive House buildings in all continents except for, I believe, Antarctica. I could be wrong about the Arctic. I think there's one up there, but I haven't checked that lately. But all the other continents, many countries, there are thousands and thousands of these types of buildings. So it is a global protocol, let's call it that, or a methodology formulated by the Passive House Institute, which is shown here in the center at the bottom. Okay, it's a German organization, and I'll talk about that a little bit more. But in North America, we've got 2, 4, 6, 8 8 affiliates. These are like regional chapters of the Passive House Network, and you can see them across the bottom there. I'm sorry, they're chapters. And then in California, we have Passive House California, which is an affiliate. Now, the only difference there is it's like a legal differentiation from between the chapters and the affiliates. But these are all part of the network. And then there's a North American Certifier Circle, which is shown here on the left. This is a group of people and organizations who have been trained and authorized by the Passive House Institute to certify passive house building. This is one of the roles I play in the world, in the world of passive house. And then we have a bunch of certified professionals shown on the right-hand side. They're certified designers or consultants, and those are the same thing. It's the same training, the same designation. What you get called just depends on whether you're officially certified as an architect or not. If you're actually a certified architect, then you're a designer. If you're not, you're a consultant. Okay. And then for those of you in the construction world, we have a thing called Certified Passive House Tradesperson, which is a separate training thread, and that's designed for people that actually build buildings. It's for carpenters, it's for construction managers, it's for general contractors. It's the same basic building science principle, but with a less nerdy orientation. I say that nicely. I consider myself a nerd, and many people in the Passive House world are nerds. You can deep dive into this stuff and get very nerdy, but for people who actually build buildings, they're generally inclined to not want to do that. Which I totally understand. I'm a certified tradesperson as well, and I've designed and built a couple of passive house buildings, so I know what things are like from that side too. So the point of all this is it is a vast network. It's worldwide. I would encourage you, if this stuff sounds interesting, I would encourage you to sign up for the Passive House Network email list. They send out lots of information. There are lots of webinars. There are announcements about training. Some of the training is subsidized. Some of it does cost money. There is a huge, huge amount of information online, kind of just like just about anything in this day and age, that you can dig into to figure out how this stuff works and how you might want to apply it to your own professional lives. So I would encourage you to start with go to passivehousenetwork.org, sign up for their email news list. I'd also encourage you to go to Passive House California and sign up for their email news list as well, because there you'll get announcements about things that are a little more specific to California. Now, having said that, I am going to be monitoring the chat, so if you have questions as we go along, don't hesitate, just throw them in the chat, and I'll try and be looking at that while I'm doing the presentation as well. If I miss the question, I'm sure Sarah, who's done this with me before, will notice those and interrupt me and say, oh, by the way, Steve, there's a question. She's great at managing these meetings because I get distracted by just yakking a little too much. So, okay, here's our agenda. We're going to talk about why Passive House makes sense. We're going to talk about the logic behind it. Okay, so that's sort of like conceptual reasons where this stuff came from and how it kind of developed. Talk about the methodology specifically. That's where we dive a little bit into what's involved in actually doing passive house work. Talk about the tools that are involved in that. And again, it's with skimming the surface on all this. And then I'll show you a bunch of examples. Now, just to sort of put this in context, the passive house methodology it's got multiple parts to it. It's really a design methodology. So for those of you that design buildings, and this applies to all types of buildings, from 200 square foot ADUs in the backyard to 50-floor skyscrapers, whether they're residential or commercial. And I'll show you lots of examples towards the end. This applies to any type of building in any climate zone, anywhere in the world. Okay. So it starts out as a design methodology, but then there's also a construction process involved too. So It's possible to design something that on paper looks and feels and smells like a passive house. But in order for it to actually be a passive house and certified as a passive house, you build it, you have to build it properly according to the details in the construction documents. You have to do some commissioning at the end. And if you do all of that stuff and you have it certified by um, a registered certifier like myself, then it becomes an actual passive house, one that you can actually say, yes, I've designed and built a passive house and we've had it certified and it performs properly. It's all about performance in the end. But I just wanted to mention that there are multiple parts to this. This is not just designing on paper. This is designing and building. Okay. So why do we care about this at all? Well, that answer at this point, I think anybody on this call, I would guess, is pretty aware of climate change and all that that implies, and that we do have a problem, and it has to do with global emissions. And buildings generate approximately 40% of the global emissions in the world, but they contribute to climate change. Now that varies by country. Unfortunately, we in the United States um, are bigger offenders than some of the smaller countries and some of the countries that are less developed. We build a lot of buildings, and they're not very well. They're not terribly high quality buildings, unfortunately. And they're, as we list here, they're unreliable, they're expensive, they're unhealthy. Air quality specifically can be a real problem. And that's a problem because we actually spend about 90% of our time indoors. And since COVID started, that might even be higher. That's an old 90% number. That's from, 5 or 10 years ago, an EPA study. So we spend a lot of time indoors. Our indoor air quality is not very good generally. And the overall quality of the buildings is not very good from an energy performance perspective, too. So these things kind of go hand in hand. So anytime you design or build a building, you have the opportunity to address these kinds of issues. And people in the passive house world think about this on an ongoing basis. We think about air quality. We think about energy efficiency. We think about carbon dioxide emission. We think about natural gas, or hopefully the lack of natural gas in a building. Our basic building stock, as it still exists today, is unreliable, expensive, unhealthy. And as the last bullet point indicates there, oftentimes these negative factors fall on those parts of our country and the world in general that don't have the resources to go out and build a super high quality, 5,000 square foot, 4-bedroom, 6-bathroom home, like we see a lot of in the Bay Area and up and down California. It's not just us, this is all over the country, but there's a lot of that goes on, and this exacerbates inequality. And so the people with the fewest resources generally get the short end of the stick. That's not a new idea or a new mission. It's just the way it is. The passive house world, we have the opportunity to address that issue as well. And there are people doing that. And again, I'll show you a few examples related to that. But we need more. We need a lot more. In the world of climate change and everything that triggers, with fires, with floods, with extreme heat, like they had up in Portland a couple of years ago. I have a colleague that lives up there. With all of these types of things, we need to look out for the occupants. It all boils down to the occupants. We need to take care of the people. Okay. And there are basically, in the passive house world, we think that there are two kinds of buildings that exist. There are those that are prepared for climate change as best as we can be prepared. And you can't possibly totally address climate change perfectly. That's just not going to happen. But you do the best you can to minimize your impact on climate change and to maximize the quality of life for the occupants. Okay. That's what we're trying to achieve. And so you either kind of go down that path or you don't. And if you don't, then you're really not preparing yourself or the people that occupy the buildings you design and build for the future. And we really need to be responsible about these kinds of things. So when we look at all these things from a passive house perspective, here's sort of like a bullet list of things that we look for. And it says here, efficiency underlies what we value most, but we don't start with efficiency. And I'll talk about that a little bit more in a couple of slides. What we really focus on are comfort. That's probably the key number one issue, for comfort for the occupants. Zero emissions if possible. Okay, we want to minimize the carbon footprint of the buildings, both as they are built and as they're lived in. We want them to be healthy as possible. We want them to be cost effective. And there is a stereotype that passive house buildings cost more to build. Well, for single family residences, yes, that's probably true. But for multifamily buildings, it's actually possible to build multifamily buildings that are passive house certified that cost no more or perhaps even cost less than a market rate multifamily building. So cost effective is a relative term. It kind of all depends. Other things we're looking for are resilient. And what that means is when we do have climate related events, these buildings survive. And just to give you one example of that, if we have a power outage in the winter, and I know in California we have a mild climate zone, but it does get chilly in the Bay Area, it gets chilly. If we have a power outage for a couple of days in a passive house, typically you won't see the temperatures drop significantly for a couple of days. And I have witnessed this in my own house, which is a certified passive. We just went away for the weekend a couple of weekends ago, and it didn't get really cold. It went down into the 40s at night, but our thermostat battery died. A simple piece of technology just died, and the heat did not come on. And the temperature, which hovers around 71 to 72 degrees, over the course of 3 days, dropped down to 69 degrees, which is still livable and comfortable. You put on an extra layer, maybe. So we're looking for that kind of resilience for climate and temperature related events. The other things we're looking at in addition is air quality. So when you have a bad air quality event like a wildfire, which seems to get more common these days, a passive house has filtered fresh air coming in all the time. And the air quality indoors, it's not going to be perfect. You can't keep out wildfire smoke 100%, but you can keep out an awful lot of it. And so our air quality on a wildfire about 3 years ago, I believe it was much better than our neighbors. So that's also another measure of resilience. It's designed to keep the occupants in a livable state, hopefully in a fairly high quality livable state. That ties into safety. Okay, so there's a direct correlation there. We want our buildings to be sustainable, and by that we mean we want them to be able to last for not 30 years or 40 years, but say 100 years, 150 years, 200 years. That's not uncommon in the passive house world. Although passive house stuff has not been around for 200 years, so that we know they're going to last that long. But there's enough building science involved here so that they can measure the performance of these buildings and determine that the factors that typically really quickly cause buildings to not perform and to start falling apart are not present in passive house buildings. So we can make them more sustainable. And the other thing we can do is we can tie in, sustainable materials and low carbon materials, things of that sort. So there's a lot of aspects to this that come into play. And then at the end of all this, for those of you who are architects, we can talk about beauty as well. You can build passive house buildings that look very traditional, or you can build ones like in this photo shown on the slide here. They're kind of modern and they have great architectural lighting, and they make for great photo ops, that kind of stuff. All of these things, all of these approaches to building design fit into the passive house world. Whatever you want it to look like, you can do that. But we don't focus on the aesthetics, we focus on the performance. Courtney says, can ERV filters handle smoke season? I've heard they can. Separate filter box can be an option. The ERV filters can handle smoke season up to a point, but you can, in addition, put additional filtering in line with the ERV filter. And I'll talk about ERVs for those of you who don't know what they are. So you can filter the heck out of the incoming air. You can put HEPA filters in line. You can put multiple filter blocks in line. You can do all kinds of stuff. There are different options on how to deal with smoke events in a passive house, but generally they perform very well. Yes. But again, I said they don't perform perfectly, but they do better than most. So what we do is what we're looking at is in the passive house where we look at fundamentals. We don't look at aesthetics so much. We don't look at daylighting, although this factor. What we do look at first and foremost is the enclosure. We want to build a high quality enclosure that drives this whole process. And if you do that and you focus on that using well-known building science and physics principles, and this is where it can get nerdy. If you focus on that, then all this other stuff that I just talked about kind of falls out of that process. So that's like a natural side effect. It's not about mechanical systems. That comes last, believe it or not. You don't solve performance problem with hardware. You solve it with the building enclosure first and foremost. And if you take that approach, you pretty much empower everybody in the whole process to build a good building. And it's, we think of this as a team sport. So people don't operate in a vacuum. Ideally, in a passive house project, for those of you who may have heard the term integrated design team, we try and do that as well, just like in other architectural types of projects or other building projects. There's more of a focus on that in the passive house world. Doesn't always work perfectly, just like other types of projects. But we try and get everybody involved at an early stage before you even have a permit or construction documents. You want to get the architect, the general contractor, the mechanical engineer, the passive house consultant or designer, the builder, maybe some of the builder key people, everybody. You want to get them in a room together and talk about what you're trying to achieve. And if you do that and you treat it as a team sport at every step of the way, it can be very successful. Okay. So, but if you take this approach, pretty much it lets everybody participate and engage and make the process work. One side effect of this is part of the passive house commercial. Okay, on the left we show a typical net zero single family home in a colder climate like much of California, at least from say, well, colder again is relative. Let's say from San Luis Obispo north, it's considered sort of a heating dominated climate, not massive heating like you'd find up in Truckee, for instance, but there is a heating requirement in the wintertime. Unfortunately, if we try and offset a heating requirement with electricity production from a PV or solar array, we have an imbalance. So we have less sun in the wintertime, but we have a higher need for heat in the wintertime. So you get this imbalance that we show during the heating season, the beginning of the year and the end of the year. And then in order to compensate for that, we put more solar PV on the roof than we really need in hopes that it balances out, your net zero requirements. So that at the end of a 12-month period, your cost of utilities is about the same as the rebates that you get from your utility for solar production. Kind of, sort of. It doesn't really work that way perfectly, but that's kind of the intent. But if you look at the right on a passive house, by empowering the building team to focus on the enclosure, you significantly reduce the heating requirement. And as a side effect of that, also the cooling requirement. That's not shown in this graph, but that comes out of this as well. So that your heating and cooling requirements get crushed significantly. Typical numbers we see are 70 to 90% lower than a code built, in this case, net zero single family home. Consequently, the electricity production you need in order to balance out, your year to year production versus consumption is significantly smaller. So you have a much smaller solar array. But then what also comes out of this is all the stuff I mentioned on one of the previous slides. You get good air quality. You get excellent comfort in the house. You get happy people. You get lower rates of asthma, things like that. And again, I'll talk about this stuff in more detail. Here's another thing that comes out of this. Depending on how you design and build your house, we can lower the embodied carbon. Okay, now this graph sort of mentioned as a tool called pH ribbon, which I'll talk about a little bit more towards the end when I talk about tools. And what we can do is we can analyze the embodied carbon that goes into the construction of the house. And we can also analyze the embodied carbon, the operational carbon that's created by the operation of the house. And this is carbon that goes into the atmosphere from heating, cooling, electricity consumption, things of this sort. So we can actually, again, if you want to get nerdy, you can drill down into all of these things to see just how big an impact a building that you're thinking of building or that you may have built and are operating has on embodied carbon, which directly impacts climate change. So there's a lot of different aspects to it. This is why I say it can be a deep topic depending on how deeply you want to dive. Passive House does work well, does play nicely with many other things. Over the years, I've also done a lot of LEED for Home certifications. I also am a certified energy analyst. I've done Title 24 for probably 20 years now. I've done zero energy ready homes shown up here. I've done Energy Star. I've done EPA Indoor Air Plus. I haven't done any of these things down towards the bottom here, but they're all kind of related. One thing not shown here is Building Green or Green Building or Cal Green, which those of you in the building industry here in California are probably aware of those. There's a lot of places that require compliance with Cal Green and or some variation of Building Green or LEED. So Passive House, because it's extremely energy efficient and it promotes extremely high quality indoor environments, it works well with all of these things. So it's complementary. These are not conflicting types of standards. They all work well nicely. The point of all of these at the end of the day is to build a high quality, high performing building that works great for the occupants. Okay. So I don't see any questions. So let's talk about the logic here. This kind came out of a lot of different things. In the upper left, we talk about the vernacular architecture in China. I sadly don't know anything about that. I've been to China, but I didn't study the vernacular architecture, so I can't really address that. Presumably, and I have no notes related to that in my presenter notes. So presumably, there has been a history in China of building design that tries to achieve these same types of things: comfort, energy efficiency, low carbon emissions, so on and so forth. But in the late 1800s and mid 1900s, there have been a bunch of activities, building design and construction that have pushed us in this direction. Here's just a couple of examples. You can see on the right, here's Germany. Lower right, here's Canada. Middle left, here's Denmark. And lower left, here's the USA. These buildings were all designed to minimize energy consumption and maximize comfort. And they had different degrees of success, but they all had some of the same basic building science principles behind the design and construction and the choices that were made. In the upper right, there's this ship that was kind of like a passive house ship. It was highly insulated. It had triple pane windows, believe it or not. And it had one little stove that even in Arctic weather would keep everybody inside very comfortable for days at a time. So it was kind of like, a passive house on the water back then. in 1978, 88, I believe it was, Wolfgang Feist, a physicist in Germany, said, wait a minute, we can do better than this. And so he kind of, with some collaborators, created this passive house concept. And this was the first certified passive house building, which is a fourplex. It's four townhouses lined up side by side. And he lives still to this day in the one on the far left. He lives on one of the end buildings. Okay. But the way this came about was he said, I'm working as a physicist. I read that the construction industry has experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong. So I made it my mission to find out what and to establish what was needed to do it right. That's how it started. Okay. And what he did was he dug into the fundamentals and he started looking at international standards for building buildings and for building performance and for measuring performance and for ventilating them and all of these things, and incorporated them into this thing that turned out to be the passive house methodology, as defined by the Passive House Institute in Darmstadt, Germany. And basically what he did was he went back to basics, much like Salman Norsrat went back to basics in her New York Times bestseller, Salt, Fat, Acid, and Heat. She basically said, if you want to cook good food, you have to focus on these four basic elements and how they interact with each other. And he kind of took the same approach without the yummy food involved. And then this is sort of the basic definition that came out of this. A passive house is a building for which thermal comfort, as defined by ISO 7730, that's one of the international standards, can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality condition without the need for additional recirculation of air. Now, let me kind of rephrase that. Notice he says, you have to bring in fresh air that's required to achieve sufficient indoor air quality. Okay, so there's ventilation that goes on, constant ventilation. And because it's fresh, that's where the air filtering comes into play. Okay, if you don't filter the air, it may or may not be fresh depending on where you're living. And so he's saying, okay, so we do that first of all, but then the building itself has to be built to such a degree that just by heating or cooling that fresh air that's coming into the building, you should be able to maintain interior comfort for the occupants. Okay, so it says nothing about the building enclosure here, but that's the massive implication. That's kind of like the only way this statement works is if you build a good enclosure and then you ventilate it. And if you do the right kind of enclosure, you should be able to heat it or cool it with virtually no extra energy. And this is, in fact, true. My house I live in, it's 1,000 square feet approximately in Berkeley. We can heat it with the heating load on it. And that's the definition of the size of the equipment needed to keep it comfortable year round. The heating load is about 1,300 watts. That's less than a hair dryer. That's less than well, maybe it's a little more than a microwave oven. It's really small. And my heating system hardly ever goes on. It maybe goes on about 40 hours out of the year. Last year, when we had a lot more rain and a lot more cold, it probably went on about twice that much. The rest of the time throughout the year, it stays at approximately 72 degrees year round, winter and summer. And the air is fresh, it's well filtered, and it's really comfortable. It's a great place to live. And once you experience a passive house, your mind sort of like goes, oh my God, why would you ever live in any other kind of building? Vito says the air conditioner needs to use a heat exchanger to recuperate the energy from the exhaust air to intake air. Yes, there is a heat exchanger involved, and I will talk about that. Yep, you're absolutely right. So this is kind of like all the things that come into play here. You've got an enclosure, and I'm going to talk about the principle of the enclosure. You've got the ventilation. I'm going to talk about that. I've touched on that, but I'll talk on it more. You've got the occupants. And so in the passive house world, we focus on the occupants. We actually have criteria that said, okay, it's not just about the air quality or the temperature of the air. It's also about, let's say, places where there could be cold spots in the building or hot spots. And that takes into account all of the activities that take place in the building. So that gets factored in. There's specific criteria that says if somebody sits next to a window, that window temperature can't be below 65 degrees approximately. If it is, they're going to be uncomfortable. Or say 75 degrees in the summertime, they're going to be uncomfortable. And then all this comes into play, and you look at the energy balance, and this is calculated. And so we look at lots and lots of stuff in much more detail than we look at things in, say, the Title 24 world. Title 24 kind of skims the surface. For those of you who are in the mechanical world, ACTA, which does load calculations, kind of skims the surface. ASHRAE building calculations kind of skim the surface. The only system I've ever seen that really drills down to the level of detail that lets you guarantee performance of a building is the passive house criteria. So, sorry, it's a little bit of a commercial here, but it's true. I do this, I experience this, and my clients do as well. So what we do is sort of the underlying thing we approach this is we don't look at how to improve something from a baseline. Okay. In the passive house world, we say, okay, in order for this building to perform, it can consume no more than this much energy for heating and for cooling, period. And it's the same number for all buildings around the world, and it's a low number. So you build a building that's going to use as little energy as possible. And from that, all of this other stuff falls out of it, all of the comfort criteria and all of the air quality, and all of those things. And this graph just sort of shows, well, a passive house consumes a lot less energy than a modern house or a leaky house. Okay. What are the units? Oh, good question, Jenna. I think you want to nerd out. It's in IP units, it's 4.75 kBTUs per square foot per year for both heating and cooling demand. And for heating and cooling loads, it's 3.17 kBTU per square foot. Okay, and I'm not going to talk about those in this presentation. It's a little deeper than we really want to go. And you write in chat, not at the moment, not while I'm presenting. When this is over, I can send to Sarah a chart that shows this stuff, and she can distribute it to all of you. Hopefully that's okay with you, Sarah. It's a very small set. It's a very small set of numbers that's very specific. I'd be happy to share. Yeah. And that's where it all starts. Okay. Okay. So, and out of this, you do get predictable performance. This chart shows affordable housing. Okay. The green stuff on the left is affordable passive housing. It's 3 different projects in Philadelphia done by a guy named Tim McDonald. He's well known. He's a very creative guy. And this is what he does in Philadelphia. That's all he does. Affordable passive house buildings certified in Philadelphia. And then here we have, okay, we have LEED is purple and blue is code. And you can find LEED homes and code homes that perform very, very well. But in the passive house world, all the buildings perform very, very well, and you're guaranteed that because that's how you design. That was the intent from the start. Okay, so that's kind of like how we got there. Now we're going to talk about the methodology. Okay, there are 5 basic elements. There are a lot of details and nuances that I'm not going to talk about, but there are 5 basic things we look at. And this is to build a good enclosure and then to create the air quality that you want in the enclosure. Okay. These are not in any particular order, but this is just kind of how we always talk about them. Okay. First one is insulation. We want the right amount of insulation for the climate zone that gets you the performance you're looking for. And that's where you shrink the heating and cooling requirements to the point where you want them. David is asking vertical scale units. I'm not sure what you mean by that, David. Can you clarify that in the chat? And I'll try and address that if I can. In the meantime, I'll roll on. Okay. So you get the right sleeping bag for the kind of hike you're taking. That's basically what we're doing. The right amount of insulation. Oh, from the last EUI slide. Oh, I have no idea. Units here. That's per square foot, but I don't know if that's watts or BTUs or kBTUs. In this case, if it's here, we're looking at it about 25 somethings per square foot. I would say that's probably kilowatts, but I don't know. Okay, I couldn't say for sure. I'd have to see a little more detail on that. Okay. Sorry, that's not a very good answer. The numerator, kilowatts is power, not energy. Yes, you're right. Thank you for pointing that out. Kilowatt hours, perhaps. Okay. I don't really worry about the scale on the units here. And I'm sorry for I'm not answering that question satisfactorily. I'm pretty sure that's what you're thinking. Not that I'm reading your mind. Okay. All right. Almost had me going down a rabbit hole there. Okay. Right amount of insulation, first thing. Second thing is thermal bridge free. Okay, a thermal bridge is someplace in a building where you can have energy moving in or out of that building. And how you define that depends on, in the summertime, it's going to be heat energy, maybe coming from outside to inside. In the wintertime, it's going to be heat energy moving from inside to outside. Depends on the climate. But this is going to happen any place where, remember back here, we had continuous insulation. Ideally, we want to wrap the whole building in insulation, but you can't do that. That's not practical. So you're going to have junction places where planes meet each other, horizontals meet verticals, windows meet walls, roofs meet walls, so on and so forth. So there are lots of places where thermal bridges can occur. What we do is when we're analyzing a passive house design, we look at all of these places, determine if they're going to be a problem or not. And we actually do a thermal analysis. It is a finite bridge analysis of those kinds of places. And we actually determine, well, is there a thermal bridge? If there is, how bad is it? Or in some cases, how good is it? And what are we going to do about it? Do we need to worry about it or not? And we do this for all these locations that are highlighted in this slide, all the intersections. And ideally, what we try and do is design all this stuff so that just by looking at it, you can say, oh, there's no thermal bridge there. We know that because it's sufficiently insulated. And we just go on. Okay. So however we approach it, we want to minimize or eliminate thermal bridges. This is some ways we analyze these. On the right, here's some more finite analysis of a couple of thermal bridges. This is a window head or window sill on the top and a window bottom sill on the bottom here. Okay, and this one on the bottom, this is actually a doorway going from inside to outside on a deck. Now, the reason we look at thermal bridges, one is it has to do with energy movement, unwanted energy movement, but also if you have a thermal bridge at a window, for instance, a poor quality window with a thermal bridge is a poor quality window by definition is a thermal bridge. It can cause mold and mildew and condensation. And this goes back to comfort, both temperature comfort and air quality. You do not want mold and mildew in a building. And we actually have criteria that you look at, numerical criteria to say, oh, okay, is this window that's defined going to be mold and mildew free and condensation free? Have we eliminated the thermal bridge sufficiently so that's not going to be an issue? The other thing we look at is the thermal transfer shown on the bottom here. This is a deck going from inside to outside in the wintertime on a thermal image. And what it's showing is all that red stuff is the interior temperature leaking to the outside. It basically is following the concrete from inside to outside because it's a cantilever deck. This is a known problem with lots of buildings, including supposedly high performance LEED buildings and things like that. Excuse me. Now, the way you eliminate that is shown on the right. You actually, you cantilever the concrete, but you break the inside from the outside with insulation. That's the pink stuff. Now, but you still have rebar going through there, but it might be stainless steel, which doesn't conduct energy as much as normal steel. So you don't eliminate the thermal bridge, but you minimize it as much as structurally possible, because this is a structural issue as well. And so you can eliminate this phenomenon shown on the left. That's what we try and achieve, regardless of the kind of building. Number 3, here is the air smoke tight enclosure. Really tight. When I talk to my clients, especially first-time general contractors, I say, conceptually, in order to do this successfully, you have to think of it as you're building a balloon. And it's got to be airtight, like a balloon is airtight. And then you're going to insulate it. So you're actually building an insulated balloon. And if you can do that successfully, you essentially have a passive house. It's more complicated than that, but just a simple statement of what you're trying to achieve, that pretty much does it. And airtight is the thing that scares general contractors the most. It makes them the most uneasy if they've never done this. And even if they have done it, because it involves lots of attention to details. But if you look at this, the benefits are huge. It reduces drafts, which has to do with comfort. It reduces moisture damage, which has to do with mold and mildew and indirectly comfort. It reduces heat loss, which has to do with energy efficiency. It gives you a way to control indoor humidity, or at least not totally control it, but it helps you control it. Okay. So again, comfort, air quality, things like that. Keeps out pollution. It lets you control the interior air. Now, it doesn't let you control the interior air, but because it's a balloon, it gives you an environment whereby you can control the interior air. For instance, the amount of fresh air, the humidity levels, things of that sort. So it creates an environment that you can manage what's going on inside the building. Out of all of these 5 principles, this is the superpower. And when I used to talk to people about renovating existing buildings, whole house upgrades, which still goes on, and that was the thing I was involved in 15 years ago, I would say, if you're going to do nothing else, make your house as airtight as possible. That will solve a lot of problems for you. Just do that. If you can't do anything else for whatever reason, just to try and achieve that to the best you can. And that's, you get a lot of benefit from that. And then here, this is sort of like my insulated balloon. Okay, you get an airtight enclosure. It's like a windbreaker over a fleece sweater, or it could be a windbreaker under a fleece sweater. It doesn't matter. You can put the airtight layer anywhere that works. It can be inside, it can be outside, it can be in the middle of a wall, it can be in the basement, it can be all of those things. But you combine that with a sweater, and you've got a passive house enclosure for the most part. Okay. Finally, we get to high performance windows with solar protection. High performance windows does not mean triple pane windows. It might mean triple pane windows. It's a lot easier to achieve really high quality indoor comfort if you have triple pane windows, but it's silly to pay for triple pane windows if you can achieve the same goals with double pane windows. So there's no point in overspending just because you can. So we look for the best quality windows that are going to deliver the performance that you need for the climate zone you're in. Okay. Now, the solar protection, that does not mean low solar heat gain coefficient windows. Okay. For those of you that live in the certified energy analyst world, you're familiar with that term. Some of you designers are. Not everybody's familiar with that. Solar heat gain coefficient is the amount of solar radiation that a piece of glass will let into the building. Okay. So what we do is we try and tune the glazing so that we get the right amount of solar radiation to the building so that the heating requirement is as low as possible. But we also don't want so much solar radiation coming in that the cooling requirement is going to be going up. So we want to make that as low as possible as well. So the solar protection might be the glazing specifications, but it might also be shading on the outside of the building, things like awning or blinds or things of that sort. So just like you want the right amount of insulation, You want the right amount of solar radiation to achieve your result. Let's see a question from Jenna. What is the typical ACH for passive house? Good question, Jenna. ACH stands for air changes per hour. That means there's a way to test the air changes per hour on a building that's using a blower door, and I'll show you a picture of that in a little bit. A typical code-built house is going to be 3 to 5 air changes per hour under these test conditions. And in fact, Title 24 Energy Code says residential buildings, they assume that they're going to be 4.9 air changes per hour. Where that number came up, I don't know. And I think multifamily is 4.5 or 7. I'm not sure. Anyway, it's high. In a passive house building, a certified passive house building, the air changes per hour is 0.6. So it's about a tenth of a code built house. And that has to be achieved in order to certify the building. Now, 1 air change per hour is still a pretty darn good building. And in fact, for a retrofit passive house, that's the air changes per hour threshold. But for a brand new residential building, single family or multifamily, it's 0.6. Okay. Back to windows. If you have high performance windows with the proper solar protection, this is what you get. You can sit right next to the windows in the dead of winter and you're comfortable. Okay, and this shows a couple of circumstances there. Now, here's the effect we're looking for. Okay, with the right windows for the climate zone, you're looking for a temperature difference between the window surface and the inside air of no more than about 5 degrees. Okay, and there are different international standards for this. The passive house standard is more stringent than these other international standards. What this does is it means that somebody inside the building is not going to feel uncomfortable. That's what it's all about. And as a side effect of that, you also get the no condensation, no mold, no mildew, none of that stuff. Back to solar radiation. Okay, we not only look at the glazing of what's attached to the building, like an awning here, okay, but we look at everything surrounding the building. And this is one huge way that the passive house world differs from, say, Title 24, ASHRAE, ACA, all the other standards that we're familiar with. We look at trees. We look at trees in the summertime and the wintertime as 2 separate conditions if they're deciduous trees. We look at adjacent buildings. We look at mountain ranges that are 2 miles off in the distance. We look at all of this stuff when we analyze the shading of a building. It's very accurate if done correctly, and it gives you a very clear idea of what you need to do in order to tune your glazing. And that might mean these specifications, it might mean the sizes of the windows, it might mean the locations of the windows, it might mean things attached to the building that you have control over during the building process, so on and so forth. But it's very detailed. Okay, and it works. I can just say that. So that's number 4. Number 5 is the ventilation. Okay, and this gets back to, I believe somebody mentioned, and I'm sorry, let me scroll back, and you mentioned a heat exchanger. This was going to be, that was Monet, I believe. Sorry, I'm not scrolling well through the chat, so if I picked the wrong person, apologies. That was not Monet. That was Vito. Yes. So first of all, we have the ventilation. I don't need to explain that. We bring fresh air in from the outside. It's filtered. It's filtered as much as you want to filter. It can be filtered reasonably well, or it can be super filtered, depending on what the occupants want. Okay. For every cubic feet of fresh air we bring in, we exhaust the same amount of air going out. So it's a balanced system. So you have no pressure differentials between inside and out. And it's filtered. The other thing we do is we have heat recovery. And let me get to that. Well, first of all, before I do that, though, I'll go to the obvious benefit. You get good air quality because of the filtering. Okay, that's one effect. But the other thing you get is this. You get the heat exchange. That's HRV, is heat energy recovery, or heat recovery ventilator. What that means is as air is coming into the house, let's say it's 40-degree air coming in the wintertime, it passes right by the outgoing air, which is typically going to be about 70 degrees. And the outgoing air, the heat from the outgoing air inside this box, this thing you see on the right here, and this thing in the center, the heat of the outgoing air gets transferred into the incoming air so that that 40-degree air, by the time it actually gets into the house, is not going to be 40. It's going to be, say, 65 or 66. It won't be 70 because this isn't a perfect thing, but it's going to pick up an awful lot of the outgoing heat and bring it into the incoming air or inject it into the incoming air. The net result is that the amount of energy required to get that incoming air back up to what you want for your indoor comfort from, say, 66 or 68 to 70 is very, very little. And this is how, by doing this ventilation with heat recovery, you can minimize the heating requirements of the building from mechanical equipment. Okay. And the same thing happens on the cooling side. If you're bringing in hot air from the outside in the summertime and it's passing by 70-degree air going outside, that 85-degree air coming in, the heat from that is going to get transferred to the outgoing air because heat moves from hot to cold, from hotter to colder. And so it helps keep the house from overheating in the summertime, and it reduces your cooling requirement as well. Okay. So that's what a heat recovery ventilator does. Now, the energy recovery ventilator, does essentially the same thing. In addition, it can transfer a certain amount of humidity when the streams pass each other. So in addition, you get a certain amount of humidity control. In California, we typically don't worry about that. It's used more in colder climates and wetter climates, more humid climates. We're not really all that humid or that cold unless you get up in the mountains or you get up, in Northern California. From Josh, in terms of HRV brands, can you recommend certain brands, high-performing ones? There are two that I know that are used in all passive house projects. One is Zehnder, Zehnder, and the other one is Brink, Brink. They're certified, they're highly efficient, they're kind of like Cadillacs. Now, you can buy other units from other, say, North American manufacturers. Both of those are manufactured in Europe, but they're UL certified and you can get them here. The Brink and the Zenders are Cadillacs. The North American brands are more like, let's say, Volkswagens. No disrespect to Volkswagens. I rented a Golf when I was in Sicily several months ago. Really nice car, but it was no Cadillac. Actually, maybe it was like a Cadillac. Let's say the Zenders and the Brinks are more like Porsches or Lamborghinis. Okay, for you car nuts out there. The other brands, while they work pretty well, they consume more energy. They're not as efficient on the heat recovery, and they're noisier generally, and they break down soon. At least from my personal experience with clients and things. Panasonic HRVs, they're pretty good. They don't move that much air. They're noisy. They're not as efficient. It's really tough to do a whole house with them. An ADU probably could do that. They're all energy recovery ventilators. They might not be the best choice in our climate zone. I have a client that put one into his 800 square foot kind of an ADU, and they're pretty happy with it, but they don't run it all the time. They don't run it at the speed they ought to in order to have the best quality air. And when they do, it is noisy. Panasonic's a good brand. I love them for bath fans, and I've recommended them over the years, but they would not be my first choice for an energy recovery or heat recovery ventilator. And then Vito says, we can use the same system, we'll move air from one side of the house, that higher temperature, to another level or part of the house, right? Yes, you do move air throughout the house. So you exhaust from all the wet spots in the house and you supply air to all the living spaces in the house. So in that sense, yes, you're doing, it's a whole house ventilation system. Okay, all the rooms, all the primary rooms should be ventilated. As far as the higher temperature, I'm not quite sure what you're implying there, Vito. If you can clarify that a little bit, maybe I can address that. by the time this air gets in the house, there should be a higher temperature. The temperature should be fairly even inside and outside if everything is working properly. Okay. Here's one other thing about HRVs and ERVs. They are insulated. They're super insulated, kind of, sort of. They are airtight. They are thermal bridge free. The good ones, the Porsches, are quiet. They're very energy efficient. They have to, in order to, the good ones have to be certified, and they consume very little energy. If you run them continuously, they consume about, for a whole house like my house, 1,000 square feet, consumes about 30 watts continuously. So it probably costs me a couple dollars a month, something like that. And we do run it all the time, summer, winter, year. And if you'll notice, these characteristics, super insulated, airtight, thermal bridge free, kind of sound like a little passive house, right? And that's really kind of what they are. There's a little passive house piece of equipment running inside of a passive house. And they do look like this on the right. So when you're designing one of these houses, you need to provide space for these. They're not tiny. You could put them in a crawl space or an attic, but you ideally want the space they're in to be conditioned space because they perform best then. But you can, depending on the climate zone again, if it's up in Truckee, you don't want to put it in an unconditioned attic or unconditioned crawl space because they'll freeze up. They won't perform properly. But in the Bay Area, you could probably do that and get away with it. David says, have good experience with Panasonic HRVs, Zender very high efficiency, but they are more complex and more expensive. Yes, Lamborghinis cost more than Volkswagens, no question. And I would say, depending on the size of the house, with the Panasonics, you're looking at a couple thousand. With the Zender, you're looking at several thousand, maybe more. As you see a high solar radiation, we can use that energy to warm other rooms that are at a lower temperature. I'd have to think about that. The hotter air from the solar radiation, well, ideally, you don't want that happening in the first place in the summertime. But that can happen. That air is indirectly going to get moved out of that room. Because if it's a living space, which it probably will be if you have excess solar radiation, it's going to get air supplied to it. It's not going to get exhausted. So the supplier is going to be delivered to the room. It's going to have a tendency to push that hotter air out of that room towards an exhaust portion of the system. But these are not high velocity systems, so they don't move a lot of air. So it's not a good strategy to look to your ventilation system to solve serious temperature imbalances. That's really more of a design issue that you should figure out before you even get to that stage. You shouldn't let that happen in the first place. Use that system in a passive house in Italy. Oh, okay. If you've done that and it works, great. I personally wouldn't rely on it. Do you want to integrate the HRV with the FAU or HVAC system? Personally, I like separate heating and cooling and ventilation system. I know of a couple of designers that like to integrate them, but it's a lot trickier to do from a design perspective. And most of the designers I know don't really have the skills or skill to do that. And I'm not sure I would trust most of them to be able to do that. Even the best mechanical engineers that I've worked with generally keep them separate because they're doing separate things and they have separate run times and separate jobs. And it's easier to manage the interior of the house if you treat them as separate things with separate purposes. That's just my personal philosophy. I'm sure there are people that would disagree with that. There is a magic box, but we're not going to talk about that, Courtney. I know where you're going with that. It does exist, but not in North America. No. Okay. In the interest of time, let me keep moving forward. These are great questions. I have to say all of these. You can do in multifamily buildings, you can do centralized or decentralized systems. Everybody gets their own little HRV or ERV on the right. Or in larger buildings, you can get big units that go up on the roof or go, in a mechanical room that can do, 8 or 10 or 20 stories, depending on how the design is done. These come in different flavors. I'm primarily talking about residential buildings because it's easiest to sort of grasp in the context that we're working with here. Okay, so to review, climate-specific insulation, thermal bridge-free connections, air tightness, that's a superpower, high-performance windows and doors with solar protection that's properly defined and figured out, and then hygienic ventilation with high efficiency heat recovery. Those are the 5 principles that we look at. Okay. Once we do all of that stuff, then we look at the mechanical equipment and we can reduce it significantly. Like I said, my heating load of my house is 1,300 watts. I don't really need a heating system except that code and Title 24 says I need one, so I have one. It just doesn't run very much or very often. Same thing with cooling. I don't have to have a cooling system, but my house stays between 71 and 75 throughout the year. And it all works. And so if you do this, you follow the 5 principles, the equipment can be much, 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 much smaller. Almost to the point where it's possible to have a passive house that does not require mechanical system, except the code says you have to have something. Okay. And once you do that, okay, if you have the right kind of enclosure, you can, with some smart controls and renewables, you just move forward and you get all the benefits that I described many slides ago. Okay, you get comfort, energy efficiency, low carbon footprint, et cetera, et cetera, et cetera. You don't fix the problem with hardware. You fix the problem by designing the right kind of building. Okay. And if you do this according to the threshold, okay, that I believe Jenna asked about, that I'll provide to Sarah, you can get 90% reduction. Okay, that's like best case. In extreme cases, you can get 100% reduction in heating demand. Okay, for new construction or retrofits, either way. And we do all of this with a tool called the Passive House Planning Package, which I'm going to talk about a little bit. Okay, works everywhere in the world. There are passive house buildings, small ones and big ones, in all parts of the globe, like I said, except for the extremes, to the best of my knowledge. Okay, so how do we actually do this? You now have a basic understanding of the design strategies and the principles. First of all, we do this with certified professional. This might feel a little bit like a marketing pitch for, oh, go out and get certified passive house training. It's good for you. Well, yes and no. I don't mean it to be that. I just wanted to give you an idea. In order for this process to work, though, there has to be somebody involved in the design process that is a certified passive house designer or consultant. It requires enough study that if you're going to put in the study and you're going to learn about this stuff to the level you need to learn about it, you might as well take the exam and get certified. It's that simple. And then when it comes time to build the building, it'd be good to have some certified passive house tradespeople in place as well, because they're going to understand what you're trying to achieve. It makes it much easier to not have to explain to them the airtightness principles and how to seal up the building, how to accomplish this stuff, because they've already been introduced to it. It is possible to build a passive house with a general contractor and their trades that have never done this before and don't know anything about this. In fact, that's how we did my house, because I couldn't find a builder in the Bay Area that was available or interested or knew about this stuff 5 years ago. That's changing, fortunately. So it's good to get the training. And of course, it'd be good if you did the training through the Passive House Network. And they do have an online hybrid schedule. It goes on for, the one started in January 18th, and the exam is on April 10th, I believe it is. And I do some of the training for this. Some of it's live, most of it's online. A ton of study materials. This course really, really prepares you for the exam. I took the exam first time about 12 years ago. It was hard, I have to say, and I failed it because I didn't study and I didn't really practice. I took it again about a year later after I applied myself a little better. and I passed. And then just because I'm doing training in this area, I decided to take it again last fall. And so I went through this whole training again. And I actually taught a 5-day live course for this training back in New York in November, early December last year. And in preparation for that, I did all the online stuff and I took the exam again. And the exam is still hard. Not as hard as it used to be, but it's still hard. But this training, if you do this, will totally prepare you for it if you apply yourself and you just do what's recommended. Jenna says, any training on how this may be incorporated into Title 24? No, this is a different animal from Title 24. Those two do not mix well. In fact, in the passive house world, we spend way too much time talking about how lame Title 24 is compared to passive house analysis. Sorry, KBEC folks. I am a KBEC person. I actually was the president of KBEC many years ago. I know what it's all about. But Title 24 is deficient compared to passive house. That's the blatant truth. Where do you sign up for the course? From Josh. Go to passivehousenetwork.org. They'd be happy to sign you up. I think the current retail price is about $2,200, but I believe Passive House California may be offering about a $500 credit for California residents. And the next course sign-ups start, I believe, in April. There's an exam in April, but then another round of this hybrid course starts right after that. How can you comply with the standard then? You comply with the standard by designing the building according to the principle and getting it certified. Okay, the certification, the closest equivalent we have in the KBEC world is when you do the Title 24 analysis, it's going to trigger a bunch of HERS requirements. And these are going to be like the commissioning requirements. The design requirements in theory are reviewed by the plan checkers, okay, or the building department, or some combination thereof. And when they review it, they say, okay, the design complies. And then when the HERS commissioning's all done, they say, okay, the building passes. The passive house world is similar, except what you do is you design the building using the passive house planning package, which I'll talk about in a minute. That's the equivalent to Energy Pro or something like that. But it's not reviewed. It can be reviewed, but if it's a certified design professional or a certified consultant, in theory, they know enough to know that they did this properly and that the design is going to satisfy the requirements. If you're going to certify, you can get a certifier who is a separate person, kind of like a building department review or a third-party review at that stage as well. You can do that. And that's not uncommon for certification. But then what happens is at the end, there's a commissioning process that's simpler and different from the HERS commissioning process. There are commissioning reports that have to be filed. And this is all reviewed by a certifier. And it's kind of like an audit, like an IRS audit. It's much more rigorous than any end of construction process that Title 24 or code triggers. So that's kind of how you comply with the standard. You do things right. There is an early stage review if you're going to certify, and there's an end of stage review if you're going to certify. Okay. Let me keep forging ahead here. Okay, so we have certified professionals, a couple different kinds. There are actually more than that, but these are the two big categories. Okay. There are certified components. The Passive House Institute in Germany has a whole process whereby they can certify components. So you can get certified doors, certified windows, certified panelization systems, certified ventilation systems. The two ventilation systems I mentioned, Brink and Zehnder, are certified by the Passive House Institute, and it's a rigorous certification. The requirements are pretty stiff. And there are other certified systems for larger buildings that are not Zehnder or Brink. Those are the two residential systems that I come across all the time. We come across certified windows in almost every project because it's just easier to certify the building if you've got certified windows. There are other things as well. Here's the list of different categories. In North America, I'd say I mostly see glazing systems, window systems, doors, and ventilation systems. and skylights. I'm starting to see those too. Okay. So, but lots of other things if you choose to go down that path. And then there's the building certification. There are 3 levels of certification, depending on the overall performance of the building, primarily in terms of how much solar energy it generates and feeds back into the grid. Okay, so the more solar energy, I'm simplifying, the more solar energy you feed back into the grid, the higher level you get. It's sort of like LEED, silver, gold, platinum, okay, that kind of thing. Although the LEED tiers are defined differently, not just in terms of solar PV, but it's sort of like the better you do, the bigger reward you get, kind of thing. Okay, but a Passive House Classic, everything I've been talking about so far, Passive House Classic is the basic target. Okay, and this Passive House Premium is tough to do, very tough, but it can be done. There are some buildings that have done. This also applies to retrofits. There are 3 retrofit tiers. Okay, and again, it's Classic, Plus, and Premium. Again, it has to do with how much energy you push back to the grid. There are 2 retrofit methods. One is performance, and that's kind of like in the KBEC world, in the certified energy analyst world, you have prescriptive method and performance method. Performance method, you have some thresholds you have to meet, and you crunch the numbers. You hit the calculate button based on the building characteristics, and if you hit the thresholds, you can certify that building using the performance method. You can also certify using the component-based prescriptive method. In order for that to work, you've got to use certified components for those major components of the building that you're replacing. Remember, this is just for retrofits, not new construction. So we have these 2 options. Most people I know do the performance method for retrofits. But, just kind of like in the Title 24 world, that's true as well, in my experience anyway. Okay, here's the tool we use, the Passive House Planning Package. It comes in metric and imperial versions. It comes in German, French, Spanish, English, Dutch, I think, maybe. Okay, that's the calculation engine. That's what you use in order to determine if a building design will meet the Passive House criteria. In addition to that, there is a plugin called Design PH, which I insist that all of my projects use. It's a SketchUp plugin that you basically build a 3D model in, and you take and import the results of that model into the Passive Planning. If you don't use Design PH, just doing the area takeoff and the shading analysis and other things in PHPP alone can be very laborious, depending on the complexity of the building. And I just won't do that anymore. I used to do that. Back in the old days, they didn't have SketchUp and Design PH, and that's how they did these things. But fortunately, technology has evolved a bit. Okay. This slide also shows something called BIM to PH, which in theory you can export from some of the more common architectural CAD packages. That is currently off the market. They're rejiggering that. So it used to exist. It exists for the older versions of PHPP, but we're really not promoting that. That's from a third party. But we'll see something like that again in the not too distant future, I'm pretty sure. Here's what a blower door looks like, okay? You put it in a door, you blow air into the building, and you see how much it leaks. Again, that's a gross simplification. And you blow air into the building to see how much it leaks, and then you turn around and suck air out of the building and see how much it leaks. And the leak numbers will be different depending on which way the air is flowing. And this is the number when you're done. You measure the interior volume of the building. And this number that you get from this test, it's software controlled, can't be more than 0.6 air changes per hour. And this can be done on small buildings and very large buildings. It's definitely a more interesting thing to deal with when it's a large building like the shown on the right, the Cornell Tech, which is a student dormitory. It can be done, but it's a little trickier. Question from David: how does PHPP compare to other modeling packages such as Energy Plus? Depends on what you're comparing. In the Passive House world, we like to think that the PHPP is the the most informative and the most accurate. What it doesn't do room by room or zone by zone analysis. It's a whole building analysis. So that's its weak spot. Uh, so in larger buildings, if you need zone analysis, oftentimes there are ways to take the PHPP and export it into something like Energy Plus if you need to do zone analysis. But now the people I know that do that have said, yes, we can do that, and that works. However, Energy Plus does not do well in doing the kind of mechanical analysis that we need for passive house analysis. It falls short in that respect, especially in, say, something like ventilation. So, you know, pluses and minuses. Energy Plus is great for certain kinds of things, but the passive house planning package is our required tool, and it works great in many, many circumstances. There are times when you may need to go with third-party tools for certain types of things. And as Jenna said, I'm assuming this is something Energy Plus does not do building control very well. Am I interpreting that right, Jenna? When you get a chance, you can just throw that in the chat. So if the real passive house rock stars that do the complex buildings do the passive house planning package, but then they will rely on additional tools in addition to the design PH and SketchUp. Yes. HVAC zone loads and equipment sizing, not for equipment sizing. All of the equipment sizing tools in existence oversize passive house buildings. I have this conversation on a weekly basis. I'll do load analysis, and I do residential building, so I don't do big building. But I'll come up with loads that are 3K BTUs, 4K BTUs, and all of the other people doing the load analysis with ACCA, ASHRAE, Title 24 can do load analysis. Whatever tool you're using will come up with loads that are 3 or 4 or 5 times larger. Okay, so those loads are not suitable for equipment sizing. The passive house loads are what you use for equipment sizing if you can get the mechanical engineers to agree with your numbers. And like I said, I have this conversation. It's not always a friendly conversation on an ongoing basis. And the designers or the developers of the building owners get caught in the middle between the passive house load people and the traditional load people. And I don't have a good answer for this other than more mechanical engineers need to get trained in passive house fundamentals so they understand it. No offense to mechanical engineers, some of them are awesome, but there's a real dearth of those that agree with the passive house approach to things. And the passive house approach to things have been proven in thousands of buildings in terms of comfort and energy efficiency. So those load calculations have been proven time and time again that they work. And I get tired of even having that conversation. Yes, it's a total rabbit hole. Thank you. Sorry, I got on my soapbox there a little bit because it can be frustrating. Yes. So yes, need other tools for HVAC zone loads, not for load and equipment sizing. Where the other tools come into play is identifying, let's say, rooms that might be. We do a whole building analysis, but there might be a zone in the building that's going to be hotter or colder than you'd really like. So you might need these other tools for identifying those kinds of situations. And then you figure out how to deal with that in terms of your equipment design, not necessarily the sizing of the load, but the design. So you might want to, let's say with your HVAC equipment, deliver more air to those rooms that are going to have a bigger temperature differential. So it can be useful for that. But again, you don't need bigger equipment in order to solve that problem. You should. You might under some circumstances. I'm not saying it doesn't happen, but that's not typically what you're going to encounter. I've seen people use third-party tools for indoor lighting analysis. Let's say daylighting. Passive house PHPP does not do daylight analysis. It has nothing to do with that. That's an aesthetic consideration that's important. And it is related to solar radiation, but it doesn't inform you about that to any degree that some people might want. Okay, I'm not saying it's perfect, but for what we're trying to accomplish and the strategic objectives here, it's what you need to use and it does the job. Absolutely. Okay. Roadmap to building certification. If you're going to do a passive house, you should get it certified. Easy for me to say because that's part of what I do for a living. I would say, though, in half of the projects I do, I get hired as a consultant to help the architect or the developer or the project team design a passive house, but they're not going to certify. And I'm fine with that. If they want to build a high performing building that's going to achieve all the objectives, that's okay. Because the extra certification step is an extra step and it can be a pain because there's more things you have to do at the end. And it can make everybody a little bit annoyed. It depends on the complexity of the building and whether you were planning for certification in the beginning or whether you treated it as an afterthought at the end. But the only way you know for sure that the building is going to perform is to get it certified because there is a commissioning process. But anybody who does a passive house inspired building is going to do the commissioning process because that's kind of one of their goals to begin with. And if you don't do the commissioning, you're crazy. You have no idea how the building is going to perform without the commissioning. And the commissioning is easy. It's a blower door test and it's a ventilation balancing system or commissioning. That's it. So it's not like it's huge. The certification process requires more collecting and submitting paperwork to the certifier. So, it's kind of like in LEED, for those of you who've done LEED, in order to get a LEED certification, at the end, there's this process where somebody, the LEED rater or somebody collects stuff and submits it to, the LEED certifying agency, or actually it would be the LEED rater. And that can be annoying in the LEED world too. That's true for any certification system. So passive house world is no different. Jenna, are the requirements for thermal mass, clerestory windows, foyers? No. You can design any way you want to, as long as you achieve the metrics. Okay, it's that simple. You can get there any way you want. Now, there are certain things to do that make it easier, like clerestory windows might work to your advantage. Thermal mass might work to your advantage. Foyers, it depends on what their exposure is and what they're built on and stuff like that. Southern exposure can be good if you're in a heating dominated climate where you need solar radiation to keep the building comfortable. Fewer south facing windows or different glazing specifications work to your advantage if you're in a cooling dominated climate. But you can pretty much define the building any way you want as long as you achieve the design objectives, which are the metrics in the PHPP. Yeah, so go wild, do whatever you want. And I'll show you some examples. Let's do that. Skyscrapers. Now, some of these you're gonna be able to tell for sure they're renderings. These are projects in process or that have been designed to the passive house criteria, but maybe they weren't built because of COVID or because of budget or because of recession or whatever. Or they're being built as we talk. Okay. So again, skyscrapers, no big deal. This one in Vancouver. Vancouver now requires their energy efficiency code now is such that they pretty much require passive house performance and or certification for all new construction in Vancouver. New York is leaning in that direction. Their code is getting very progressive and very tough over the next 6 years, I believe it is. Massachusetts, we're seeing the same thing. So we're seeing pockets of code requirements around the world. Belgium, I think it is, has a whole city that for at least 10 years has required all new construction to be passive house certified. So this kind of stuff is happening. These are not just good looking pictures. Okay. Here's Vancouver and New York and Boston, I believe, or Boston, yes. And Chelsea and New York, that's built. Vancouver and Boston are in process. Here's Brooklyn. Okay, this is affordable housing. The one on the left is in process. The one on the right has been built. That's in East Harlem. And these are built at or below market rate. Okay, so this may sound complicated and difficult, but they can do it for no additional money or for less money. So why wouldn't you do this? There's absolutely no reason not to do this for any kind of building, really. This is a set of row houses in somewhere in the UK, in Norwich in the UK, award winning. I think this is a really great looking project. Very energy efficient, just comfortable, gorgeous, great neighborhood, all of that stuff. Museum, you can do a museum. Now, the one on the left is a rendering, still Vancouver. Okay. The one on the right actually exists. That's in Austria. And again, you can see most of these architectural styles are kind of modern, but they don't have to be that way. Okay. Government buildings. The one on the left exists, although that looks like a rendering to me. The one on the right, I think that exists also. That's a real intriguing building. An archive. Every time I see this, I look and say, what the heck is that thing? There are no windows. How can they get, satisfy the heating load with no solar radiation? Because that's the world I come from. But it's a certified archive of some type in the UK, and they do something there. And this last time I looked at this slide, I got a close. It looks like there's writing on the exterior walls. I'm not sure what that's all about. I'd like to know more about this building. It's mysterious. Universities, these are a real thing. Okay. And this is all in Maine. Great looking building, a great site. I wish I'd gone to school there. More universities, these are all real. Okay. This is in the UK, both of these. A rec center with a swimming pool. Now think of the humidity load there, having to deal with that. So one passive house nuance is the interior humidity cannot dip below 30% at any time during the year. And in a case like this, the humidity cannot also exceed a certain threshold depending on the climate zone. And how do you control humidity in something like this so that the indoor humidity is always manageable and nice and comfortable for everybody all the time? To me, that's a real engineering feat. I think that's fabulous. Townhouse retrofit. Okay, there's a lot of these in New York. There's in New York proper, there are lots and lots of townhouses getting retrofit. Same thing is true. We're seeing this in Boston and the Northeast. There's more of this going on in the Northeast than there is out here so far. That's because they have a lot of older buildings that probably are worthy of a retrofit out here. We've got a lot of younger stiff framed buildings that maybe deserve to be knocked down and rebuilt. But retrofitting is more of a challenge, and there's the value of the real estate is not considered quite as important. Yeah. And then homes. Okay, here's a couple of traditional like buildings. And then again, more modernist stuff. You can build any kind of building this way. And I think I've run over a little bit, so good thing we're at the end here. So here's the commercial. Well, build your future. If you're in the building industry, you're crazy if you don't dig into this and build stuff doing it this way. It's the only way to build. When I first drank the Kool-Aid, if we say 15 years ago, that was my thought. I was like, my God, why would I do anything else? And that's when I started giving up doing LEED and doing Title 24 and doing green building and doing all that other stuff because it all paled by comparison. And I still feel that way. So if this at all seems interesting to you, yes, get trained and dig in and do it. And when people come to me and say, I'm thinking about building kind of sort of maybe a passive house inspired thing, I always say, no, just design it and build it and certify it. Don't beat around the bush, just do it and stop fooling around. And some of them take me up on that and some don't. So I don't see any more questions. I'm sorry to run it over. But I'm going to pass it back to Sarah.
Yeah. And actually our class today is a 2-hour class, so we have until 11:30.
Oh my God. Oh, I was told an hour and a half. So, okay. Well,
Yeah, no.
Questions, go wild.
Yeah.
Yes. Okay.
Yeah. So I'll just run through my closing slides and then we can just open up for any questions. I always add this slide in here, even though this isn't a passive house coach service. This is our Title 24 Energy Code Coach service. So if anyone out there has Title 24 Part 6 or Part 11 questions, this service is for you. It's free. You can submit a web form or you can call the hotline, and we have Inbalance Green Consulting as our coaches, and they can answer any questions.
And I know the coaches, they do a great job. So you can't beat this resource. Even though I speak ill of Title 24, you can't build in California without it. So, you learn to live with it and work with it as best you can.
And then for today's course, there are AIA learning units, and I will send your attendance over to the Passive House Network, and they'll submit those learning units on your behalf. If you need to send me your AIA number, my email is there on the screen. And then you will also be getting a copy of the slides and a link to the recording in your inboxes. And then I just listed a couple of upcoming courses. The one that I've already added into the chat, but again, I would just want to highlight is 3C Ren is offering a free certified passive house designer consultant training. It's that hybrid cohort that is coming up. So last year we did an in-person training, but this year we're focusing on the hybrid online cohorts. So that training is available for those that live or work in our Tri-County region. I can add the link into the chat again for those that are interested. But again, it's as Steve has mentioned, it's a really good training, really good resource. And for anyone that is wanting to do more of the in-person, we'll be doing that next year. So we're alternating online and in person.
Yeah, great.
But yeah, with that, we do have about 20 minutes. So if there's more questions, feel free to unmute or raise your hand or add them into the chat.
Okay, I'm seeing. Okay, thanks for the resource. Thank you for your comments, by the way. Question for Jenna and or anyone else. If you are interested in the criteria in order to hit the Passive House certification metrics, I could send a simple one-page thing, or I could send the certification guide, which has lots of detail, and it's about 20 pages. So anybody want to vote for the one pager or the multi-pager? That would help. I can provide them both, I suppose. Yeah. Okay. Multi. Okay. Thank you. I had a feeling that was going to be your answer, Jenna. Thank you. And then I scrolled past something, or something scrolled past me. I thought I saw a question. The NorCal equivalent of the Passive House training cohort. There is, you can sign up for any of these training cohorts, but there's none that's free in Northern California. I've talked to PG&E about doing that, and they're kind of sort of interested in the idea, but they're hesitant. They're funneling their training dollars in other directions at the moment. But I keep sort of pounding on their door saying, okay, come on. You have the money, just, let's get 20 people enrolled. It's not going to cost you very much. You're PG&E, for goodness sake. But that's a long discussion that we'll keep having. So currently there's nothing, but if you're willing and able to pay the fee, you can sign up for the hybrid course outside of 3C Ren territory. And again, I'd say check with Passive House California to see if they've got some kind of scholarship of sorts, but I know it's not a full scholarship. Yes, another rabbit hole. Yes, you're absolutely right there. Yeah. Let's see. And yeah, I don't see any other questions. So I want to thank you all again. There were a lot of good questions. We dug down a little deeper than I expected, but that's good. You can really nerd out on this stuff, and that's kind of fun. Jen, I'm curious if you anticipate passive solar manufactured homes. Are the site-specific details too much to surpass? Passive solar manufactured homes. You're talking about panelized, I presume. Yes. That is being. Oh no. Oh, please clarify. Passive home. Certified passive homes or passive solar? becoming a kit. No, I don't see that happening. Okay, that explains it. Yeah. No, the site-specific details are too much to surpass in a lot of cases. Um, I have seen some architects that have done some studies like that, where they've done some hypothetical designs, but they were pretty much site specific, and they were more multifamily than single family. Um, if you could if you could find a development where there were no shading obstructions of any kind, and you could take this kit and orient it any way you wanted to on the site. Okay, I think it would be possible to do that, but that presents a lot of development challenges. Um, I'm going to make a note, Jenna, about anything in that respect I can find. I only know two architects who have done that, but it wouldn't surprise me if they know about a few more attempts. Okay, so let me see what I can find. And if you put your email in the chat, I'll send that directly to you. I'm guessing it's going to get you through trcsolution.com, or I don't know if you guys read .org, trccompanies.com. Oh, okay, I'm going to need a minute to write that down. That's a mouthful. Get a larger piece of paper because my handwriting is terrible. It looks like scribbling. Oh, actually, I'm going to do this, Janet. If you would send me an email, this is going to be so much easier. My email is, I'm going to put that in the chat. It's easier to remember, I think. If I have to spell it right, my typing is almost as bad as my handwriting. There you go. Yeah. And if you just send me a reminder, and I'll dig out what I can. And these architects that I know that are doing this stuff, I mean, obviously TRC is a well-known entity. I used to do a lot of rebates with you guys and things. And I've worked with some of your folks there. I'm sure these architects would be happy to talk to you about this kind of stuff too, especially if TRC Companies is in the mood to help promote a pathway towards more passive house projects. They would probably talk your ear off, would be my guess. Yeah. So cool. Good. Good. What else do we have? I don't see anything.
David did have a question. How about domestic hot water heating? But I don't know if that was in reference to something specific. So David, feel free to clarify.
Oh, okay. I didn't see that one. I'm sorry I missed that. Yes, as far as domestic hot water goes, it's an interesting phenomenon that you run across once you start doing this. Once you crush the heating and cooling requirements so that they're minuscule or non-existent, domestic hot water is the next biggest energy consumer by far. And so what we find people doing, first of all, is putting in heat pumps, because they're the most energy efficient form of hot water heating. Okay, that's the first thing. The second thing we find is that they have to worry about the heating. I'm sorry, not the heating, the heat that's generated from the tanks and from the hot water line, because they can go towards, they create what are called internal heat gain. Now, if you're trying to heat a building, it's okay to have heat coming off of the hot water equipment. But if you're trying to cool a building, that's not a good thing. Okay. And so, first of all, you want to look at the efficiency of the equipment. Second of all, just like in Title 24 and other sustainability types of approaches to buildings, you want to minimize the sizes and the lengths of the hot water line. Okay. And so you want to optimize your hot water, which is just common sense anyway. And so we find that oftentimes, unless the building is really built far and above the passive house requirements, it's like kind of right on the edge so that you could certify it, but it's not like a superstar performing building, but it's close to the edge. Sometimes the hot water performance can push it over the edge. And when we certify a building, we actually have to get from somebody, the general contractor, the plumber, somebody that actually built the building, we have to get a diagram of the hot water lines and where they run and how long they are and their sizes and their insulation level. And we plug that into the PHPP and it uses that to calculate the internal heat gain. And from that, it determines, whether that's going to help you, in the heating season, or it's going to hurt you in the cooling season, or maybe it's going to be just right for both situations. So that can definitely have an effect on a building, more so than you might think in these super performing buildings. And that's kind of fun. And this is where, I talk about certification can be a little frustrating. You say at the beginning of the process to the general contractor or to somebody, okay, well, your plumber is going to need to send us a diagram of the hot water lines, and we're going to need pictures of the hot water lines. And they get through the roughing in the building and they're putting in all the plumbing and all that stuff, and everybody's going really fast because they want to, get paid and move on to the next job. And the general contractor will forget to make pictures, and the plumber will be like, I don't have time to make a diagram. Okay. And so you get to the end and it's like, okay, well, I need that picture. I need a couple of pictures and I need that diagram. And everybody's going, oh, geez, why don't you just leave me alone? I don't have time for that. And like David said, plumbers don't do that stuff. They drill and run pipes. Yes. And in my experience, when they drill, they wreak havoc too. Um, So, but yeah, good question. Good question. Stephen, sir, thank you. Excellent. Thank you, Walter. Appreciate it. Yes. And thank you, Courtney. Um, and thank you, Josh. And everybody else has scrolled past. So I'm glad you all could make it and you just stuck it out. That raises my hopes that there's definitely some interest somewhere in this group to do this. And I think that's an excellent idea. Okay, we can hang out a few more minutes, see what's going on.
Yeah, we can just see if there's any other questions. But if not, feel free to hop off, and thank you all again for joining us.
Yeah. Oh, can I mention one more resource?
Yeah.
Besides passivehousenetwork.org and Passive House California, and I don't know the web, I think it's passivehousecal.org. There's an organization called Passive House Accelerator.com, spelled just like it sounds, Passive House Accelerator. They do weekly webinars, sometimes more than one a week, and they've been doing this for a couple of years. And they have and it's all free. I'd say go to their website, sign up for their email list, and all of the content that they've done over the last couple of years, they've recorded, and it's all online. There you go. Catalyst for Zero Carbon Building. Yes. And if you just want to dig into this more, I would say sign up for a couple of the weekly webinars where you have designers and architects and engineers talk about their projects. They showcase projects or they showcase technologies. And if you just do this once a week for an hour, you can learn an awful lot. And it introduces you to the Passive House community, which is a very, what's the word I'm looking for? Cooperative community. They like sharing information, unlike some other professions. It's not competitive. And so there's just a huge amount of information out there that's been vetted, and these folks put together. They also have, printed stuff. They have a couple of blogs. It's just mind-boggling. So I would say out of all these things, all the things we've already mentioned, check out Passive House Accelerator too. They're doing a great job. And I drop in on them. I used to drop in a couple times a week. Now I'm about once every 2 weeks. Because after you see project presentations about the same kind of project 4 or 5 times, at least for me, it takes me 5 times, then it sinks in. And I have work to do, so I can't just be looking at webinars all the time. So thanks for the link, Sarah.
Yeah, no problem.
Okay.
Okay, yeah. Don't see any other questions. So yeah, we can let you all go. Thanks again, and thank you, Steve, for a great course.
Sure. Thank you for managing, and thanks to Naomi in the background. I know you're there. I look forward to seeing you in a future webinar. Yeah.
All right, thanks all. Bye.
Okay. Take care. Have a great week.